Yes, hello students. Yes, let us begin with today's lecture. Let me check just once my voice is audible and the screen is visible. Yes, let us begin with today's lecture. Okay. So, hello everyone, I welcome you all on the platform of Global Online. As we know, friends, Global Online platform has launched a complete course for upcoming CTET examination 2023, and in this particular whole course we'll be discussing the whole syllabus of CTET examination. In this particular series we have start up with the mathematics paper 1 as well as paper 2. In today's lecture we'll be talking about topic named as mensuration. In mensuration we have already discussed the 2D structures. In today's lecture we'll be talking about the 3D structures, like how to calculate the questions based upon the cube, cuboid and cylinder. Before moving into the video, friends, for the central teacher eligibility test, a complete course has been launched by Global Online platform, and in this complete course you'll be provided for paper 1 as well as for the paper 2. Simply you have to download the Global Online application from the Play Store, and you can contact us on this given WhatsApp number, which is 8669316919 or 8179138413. These are two numbers from which any one of one number you can contact and get enrolled to the course. The highlighting feature of this particular course is you'll be provided with one-on-one mentorship, so that you can score maximum marks in the examination and can have guaranteed selection. Global Online application, as I have told you, is available on the Play Store. With such a logo you can install the application from Play Store. Once installed it, open the application, you'll find such type of interface. In this particular interface there is an icon named as Store. Click on it, you'll move to the page called as My Courses, and in My Courses there is a search tab where you have to type a CTET. Once you type CTET, course along with the fees will be displayed downwards, and hence you can get enrolled to the course. So this is the very first question of today's lecture. Let us start up with the three-dimensional structures. Okay, so the first question displaying on the screen is talking about, if the diagonal of a cube is of, then the total surface area of the cube is what? Please note the options for this particular question. Option number A is 3I square, that is 3L square, not I square. Second option is under root of 3L square. Option number 3 is under root of 2L square, and option number D is 2 square, 2L square. Okay, so these are the four options. So before understanding the answer of the question, one thing that you have to understand is the shape of the cube. Okay, so I'm drawing here the shape of cube. Please note the first point here, that in any shape, in any cube shape, we'll find length, height as well as the thickness. Both of these three features are equal. Either it may be the length, height or thickness, all of them are equal. All of them are equal. A cube has 6 faces. In these 6 faces, you can laterally see 1, 2, 3, 4 faces. Lateral faces, it means actually this surrounding faces. This is the first face, second face, the back one, and this one. Okay, so basically the lateral side faces are nothing but the lateral faces. So there are 4 lateral faces of this, and if we count this upper and the lower face, that is the top and the bottom face, so these are the 2 rest faces. Okay, these are the 2 top and bottom face, and other lateral faces are 4 lateral faces. Hence 4 plus 2 will give us total 6 faces of the cube. In this cube there are 12 edges. There are 12 edges. Okay, what are edges? Basically edges are these lines. These are the edges. These are the edges. These are the edges. Okay, so if we count all these edges, there are total 12 edges. On the upper side we can find 4. Similarly on the lower side 4, and the lateral side 2. Okay, so there are total 12 edges. Next is, whatever the faces are there in the cube, they are in the square shape. They are in the square shape. Please note this. Okay, so this was regarding the basics of the cube. In cube we can find the length, height as well as the thickness. All of the 3 things are equal over here. In cube we can find 6 faces, in which 4 are lateral faces and 2 faces we can find in the top and the bottom. There are total 12 edges, and the faces in the cube are square in shape. Okay, so other than these, there are total 8 vertex also. There are total 8 vertex. Vertex means what? These corners are vertices. Vertex. There are total 8 vertex. Okay, 4 above and 4 downwards. Okay, there are total 8 vertex. So based upon this, there is also a Euler theorem. Now that is not of importance currently regarding this question. So based upon this question, I have told you the features of the cube. Okay, so length, height and thickness are equal, 6 faces, 12 edges, 8 vertices. The faces are square in cube. Okay, so I'll rub it out. I hope you have noted all these features. Second thing is formula for the cube. So in formula, the lateral surface area, now we have seen what is the lateral surface, right? We have seen what is the lateral surface. All the spaces we can say, or all the sides except the top and the bottom are the lateral faces, except the top and the bottom face. Okay, here, so if they ask us to find out the lateral surface area, so the lateral surface area, as we know, each face is a square. We are going to take, there are 4 lateral surfaces. For 4 lateral surfaces, 4 squares, we are going to take 4a square as the lateral surface area. Directly question can be asked upon these formulas. Okay, second formula for the cube is total surface area, that is 4a square, that is the lateral surface area, plus the top and the bottom, that is 2a square, that will give me 6a square. So the total surface area for a cube is equal to 6a square. I hope you have got this. Okay, and the volume of the cube, for that formula is a cube. Volume of cube is equals to a cube. And sometimes based upon the diagonal, as mentioned in the question as well, question can be asked. So for diagonal of a cube is equals to under root of 3a. So these are the 4 important formulas. Lateral surface area is equals to 4a square. Total surface area 4a square plus 2a square 6a square. Similarly, volume a cube. Diagonal of the cube, that is equals to under root of 3. Now based upon this formula, we are going to solve this question. Okay. So what is given? If the diagonal of the cube, diagonal is given with length L, then the total surface area of the cube, we have to find the total surface area of the cube. Okay, we know what is the formula for the total surface area now. We have already discussed, that is equals to 6a square. Also we know for the diagonal is equals to under root of 3a. So diagonal given in the question, mentioned in the question is L. L is equal to under root of 3a. A is what? A is actually the side of the cube. Okay. So A is equal to under L upon under root of 3. Can I write like this? Yes. So this is the side of the cube now. Now putting this into this total surface area formula, I can get the total surface area of the cube. This is equals to 6 into A square. What is A? L upon under root of 3 square. This will give me 6 L square divided by, now what is the square of root 3? Root 3 into root 3, right? This will give me 6L square divided by 3. 3 2s are 6. So 2L square is the answer to your question. I hope you have got the question. The total surface area of the cube with the diagonal of the cube with length L is 2L square. Got it? Moving on to the next question. The volume of the cube is 5832 centimeter cube. This is centimeter cube. Find the total surface area they have asked us. Option given are 1672 centimeter square, 1944 centimeter square, 1536 centimeter square, or 1824 centimeter square. So, for this particular question, what is given in the question? The volume is given. What is volume? 5832 centimeter cube is the volume mentioned. We know the volume of the cube. Yes. Volume of the cube is equals to A cube. So can I write A cube is equal to 5832? Yes. If A cube is equals to 5832, then what will be the value of A? Basically, 5832 is the cube of 18. 18's cube is 5832. So taking cube root on both the sides, I can get A is equal to 18. We got now the side of the cube. Yes, we got the side of the cube simply. So now we have to find out the total surface area. Yes. In first thing what we have done, from the basis of volume, whatever the data was given, we have find the side's value. So we got the side of the cube is equal to 18 centimeter for example. So now we have to find the total surface area. As I have mentioned before, the basics of the cube, in that I have told you what is the total surface area of the cube. The total surface area was 4a square plus 2a square, that is equals to 6a square. Don't write this actually, I'm just writing it to make you things understand. Okay, so you don't have to just rectify the formulas over here, you simply have to understand them, so I'm writing here. Okay, so here the 6a square is the total surface area of the cube. Putting this particular value of the side in this particular formula, we can get the total surface area. So total surface area is equal to 6a square. This can be written as 6 into 18 square. This is equals to, what is 6? 18 square. 18 square is 324. So simply after multiplication, we can get the value of value of total surface area of a cube. So the total surface area of the cube for the given cube in the question is 1944 centimeter square. So for this particular question, the option number B is the correct answer. Option number B. I hope you have got this. Okay. So in question they have mentioned us the volume. Based upon the volume, we have find out the value of the side of the cube, and we have inserted that particular value in the formula of the total surface area of a cube. Okay. So moving on to the next question. A cube of maximum possible size is cut from a hemisphere of radius Square root of 6. Basically, this SQRT, it means, I'll write here, this it means under root of 6 centimeter. Okay. One identical cube is placed next to this cube to form a cuboid. Find the total surface area in centimeter square of a cuboid. So to understand now this particular question, you have to come across a formula where we are actually inserting one cube. Okay, we are actually inserting a cube in a hemisphere. For example, this is the hemisphere I'm drawing here. Okay. Okay. So in this particular hemisphere, actually we are inserting a cube. So the cube here is of maximum size, possible maximum size. Okay. This actually I'm not able to draw here properly, but try to understand that this is a hemisphere, and inside this particular hemisphere, a cube has been enclosed. Okay, this is the cube that has been enclosed in a hemisphere. So what is mentioned here? They have mentioned the radius of the hemisphere. What is the radius of the hemisphere? Radius of hemisphere is under root of 6 centimeter. Inside hemisphere, we are actually inserting a cube of maximum size. Okay, now a cube of maximum possible size is cut from a hemisphere of radius under root of 6 centimeter. After cutting that, we are actually placing this one cube next to the another cube. Okay, we are actually placing this one cube with next to the another cube. So this is going to form a cuboid now. Yes, this is going to form a cuboid. So we have to actually tell us, after connecting these two certain cubes, this is actually sticking exactly to each other. Okay, so try to understand, after connecting these two cubes together, they are forming a cuboid. They are forming a cuboid. So we have to find the total surface area of the cuboid. Okay, so to understand this, first one thing, as I have told you, when a cube is inserted inside a hemisphere of a given radius, of a given radius, just I'll draw it once again. Okay. So now here the radius, if for example is r, and at the same time this is the r radius, and as well as I told you, the side of the cube is for example a. The side of the cube is for example a centimeter. So here the side of, in case of a hemisphere with radius r, side of cube can be represented as, side of the cube, that is a, can be represented as under root of 2 by 3r. So this is a formula which is very much important, can be directly asked in your examination. What is it? That when a cube is actually placed inside a hemisphere with a radius r, then the side of the cube can be represented by under root of 2 by 3r. Under root of 2 by 3r. So based upon this formula only, we have to solve the question now. Okay. First thing that you have to look here is, first what we'll do, we'll find out the side of the cube. 2 by 3r. Okay, so as per the question, what is the radius? Radius is under root of 6, square root of 6. Yes, so
Can I write like this? Yes. So this will give me 2 centimeter. How come 2 centimeter? This is giving me actually 3 2s are 6. Yes. So under root of 2 into 2 will give me 2 centimeter. So the side of the cube I have got is not 2 centimeter. What we have to find out? We exactly have to find out the total surface area. Now look here. Before that, now this is the cube. They have told in the question that cube has been placed on the other side of the other cube, right? For example, this is the other one cube. Okay, so these two cubes have been placed connected to each other. They have placed connected to each other. So the side of 2 centimeter and this is also the side of 2 centimeter. Now the dimensions are going to change. The dimensions are going to change. That is, length is going to be 4 here. Length of the cuboid is going to be 4. Cube is forming cuboid because two cubes are connecting to each other. So they are forming a cuboid. Now the length of a cube which was 2 centimeter now will change to 4 centimeter. Yes. So here the length is going to be 4 centimeter. Breadth will be remaining as 2 centimeter and height also will remain as 2 centimeter. So here what is the now total surface area of a cuboid? For that formula is, note down again a formula, total surface area of cuboid. Formula is twice of LB plus BH plus LH. Okay, so twice of, what is the length? Length is 4, breadth is 2 plus breadth is 2, height is 2 plus length is 4, height is 2. We'll get 2 into 8 plus 4 plus 8. This will give me 40. So the total surface area of a cuboid is 40 centimeters square. Got it? So correct answer is option number B. Moving on to the next question now. The dimensions of a go down are mentioned, which are 5 meter into 7 meter into 4 meter. What is the largest number of parcel of dimensions of 25 centimeter, 50 centimeter and 25 centimeter can be accommodated in the go down? So first thing that you have to understand here is, for example, this is a go down. This is a go down. Okay. The dimensions of the go down are mentioned, that is 5 meter, 7 meter, 7 meter and 4 meter. Yes. So whatever the dimensions they have mentioned here are in meter for go down. Okay. So what we can do is we'll convert this into centimeter. So as we know, 1 meter is equals to 100 centimeter. So I can write 5 meter as 500 centimeter. Similarly, 7 meter as 700 centimeter and 4 meter as 400 centimeter. Now what they are saying is, if we are now in this go down, if we are starting to add some little parcels, such parcels, if we start adding up the parcels of dimensions 25 centimeter, 55 centimeter and 25 centimeter. So how many parcels can be accommodated in the go down? For example, this is the parcel. This is the parcel and the dimensions of this particular parcel have been mentioned over here. Okay, that is 25 centimeter, 50 centimeter and again 25 centimeter. So here what we have to do, how many parcels can be actually added in this go down? To understand that, first thing, go down size is 500 into 700 into 400 divided by the size of the parcel, which is 25 into 50 into 25. Got it? Yes. So if we divide it, we'll get the total number of actually how many parcels can be actually added in this. So what I'll do here is I'll just simply divide it now. This will give me 28. This will give me 10. Yes. And yes, right. Okay. And 25 ones are 25 six are. Yes. So actually the answer is going to come with unit at the unit place 0 compulsory, because we are going to multiply these particular numbers with 10. So the unit place digit is going to remain 0. So this will be the particular answer. Yes. Got it? So what I have done, I have simply divided the dimensions of the parcel with the dimensions of the godown. Okay. Similar is the next question. What is given now? The size of a small pocket of a biscuit has been mentioned, which is equal to 12 centimeter into 15 centimeter into 3 centimeter. For example, this is the parcel of the biscuit, small packet of the biscuit. Okay, sizes have been mentioned: 12 centimeter, 5 centimeter, and 3 centimeter. A wholesaler wants to pack these small packets in a box. For example, this is that box. This is that box in which that wholesaler has to pack all these biscuit packets in it. Basically, it's going to keep all those biscuit packets in this whole box. Okay, and the dimensions of the box have been mentioned, which is 0.5 meters, 0.25, and 18 centimeters. This is in meter. Okay, now can I convert this meter into centimeter? As we know, 1 meter is equals to 100 centimeter. Again, 0.5 will become 50 centimeter, 0.25 will become 25 centimeter, and 18 centimeter is as it is. Okay, now same, the dimension of the boxes, which is dimension of the box, which is 50 centimeter into 25 centimeter into 18 centimeter, divided with the dimensions of the small packet of biscuits, that is 12 into 5 into 3. 5 5s are 25. Yes. 3 6 are 18. 6 2s are 12. 25. So 125, that is 25 5s are 125 is your answer to the given question. So 125 biscuit packets can be packed in this particular whole box. So this is how you have to understand that such type of questions can be asked in the examination and how to tackle these questions. Okay. I hope you have got the question. So yes, so this was the end of today's lecture. We have seen some of the few questions regarding the three-dimensional mensurations which is required for paper 1 as well as for the paper 2. Now if we'll just solve the questions of cube and cuboid, then that will be enough for mathematics paper 1, CTET paper 1. But if you are preparing for paper 2, you have to solve both the cuboid, along with that cylinder is something that you have to solve, and sphere as well. Okay, so I'll take it in the next lecture. Thank you for watching it. If you're liking the video, please hit the like button and let me know in the comment section if you have any kind of suggestion and the doubts. And if you're new to the channel, please subscribe it. At the same time, if you want to get enrolled to the course, you can contact us on this given WhatsApp number, which is 866 931 6919 or 8179138413. So thank you for watching the video. Have a great day, everyone.